an enterprise. It's actually a bunch of chess games that you play. Can't lose in any of the games. Lots of the algorithms have been around since, as I said, 60s, 70s, but they didn't predict better than 70%, 80%. Now they predict 97%. They know what you're gonna buy, what you're gonna think, what you're gonna vote. I think it's a dark thing. I think the fact that someone knows what's gonna be the results of the US election in a few months, or someone can impact that dramatically with AI, this is not a good thing.
Welcome to another episode of Israel Tech. I'm here in the beautiful offices of SQream, here with the co-founder and CEO, Amigal. How you doing?
Hi, nice to meet you.
Nice to meet you too. So the first thing I noticed when I came in, there's a lot of chess.
Yeah.
So what's up with chess? Is it your love of chess? Why is chess such a big component of, let's say, the culture and even the decor here?
Yeah, so I'm a big fan of chess. I've been playing chess since I was 8 or 7, so it's part of my DNA. And it's not only me. A lot of people in the company, they like to play chess. It's a tactical, strategic, and lifestyle kind of a game. And so we like to play with each other. We like to think on stuff both strategically and tactically. And in many ways, I think a company, a startup, an enterprise, whatever it is, it's actually a bunch of chess games that you play. For example, in a startup, you have a few boards of a game. You have marketing, you have sales, you have technology, you need the best team, and you need this and that. So everything is a chess game, and you can't lose in any of the games. You have to at least draw in order to win when you run a company. So in many ways, when I talk with people here, I ask them to think long term, strategically, and shorter term, tactically, in order to achieve the goals. And you need to think like that also when you play chess. So it's part of the message. This is a long, intelligent, challenging game that we are doing here, and we want to win.
So when you play, do you think about work at the same time, or do you see it as a muscle that helps business, or do you think it actually stimulates in real time, helps you stimulate how you're going to expand and improve SQream?
So first of all, when I play chess, and I don't play as often as I want, I enjoy it.
Right.
That's before everything else. It's a mind game. It's part of my own maintenance of my brains and well-being. This is number one. And I try to focus on that, because when you have your brain muscle trained, then you execute better in other places. But sometimes when I have a certain position with certain challenges to tackle, sometimes I think about business life and other parts of life as well.
So how many years ago, is it decades ago already, the computer has beaten the grandmaster in chess, right? What do you think, how much, SQream's all about AI, machine learning, and there's this, and you're the human element of the chess, and then you have the computer overtaking the human element, which is a fascinating theme for a chess lover and the founders of SQream.
I remember the first time. It was publicly known when Deep Thought of IBM beat Garry Kasparov in the early 90s. That was a big thing, right?
Yeah, so I bring it up.
And talk about machine learning, AI, data science. The algorithms there were not as advanced as today, and the data was not as advanced as today. So it was a real achievement at the time. It's nothing like anything that we do today. Today we have more compute power on a mobile phone than the rocket ship that we sent to the space, in the 80s. It's like unbelievable. So it's completely different what we see today in compute algorithms, data, AI, than what it used to be. In SQream, what we do is actually enabling a faster and more accurate data processing and algorithmic results, right? So yeah, so with that, what we are experiencing today is, I would say, a lot of different technology tsunamis, but I would like to mention main three. And that will correspond with what we just spoke about chess and computers. So number one, everybody knows about it for more than a decade. It is big data, right? Big data was iconed in between 2000 and 2010. And we saw plenty of companies making big data available. So lots of data on plenty of stuff, including chess games, but also on human brains, on our DNA, on our travel, on our everything, any aspect of our life. We are collecting data, and businesses are religiously understand today that the data is going to be the difference, so they collect the data. The other thing that happened is algorithms, right? Algorithm advanced quite a bit, including things that are under the umbrella of AI, but they are not AI. You know, statistical algorithm, data science algorithm, and of course, machine learning algorithm, deep learning algorithm. And algorithms without a name, but they monetize more and they predict more accurately with all the data that we mentioned earlier. So, lots of data implemented on great algorithms. By the way, some of the most common algorithms that are being used today are here from the 70s, but they are just more accurate now with the data.
Well, why is that? Like,
because there is the data.
How would you define a good algorithm?
Just a second. Just before that, okay. I will finish my the thingy about the technology tsunami. So lots of data, algorithm that using all the data are monetizing much better and predicting much better, and you need to compute all that. So what they did until recently, they put a lot of machines in parallel, CPU, machine, corridors full of racks of machines in order to compute all that. And then came NVIDIA, right? So NVIDIA is a very successful company, and the reason why they are like the hotshot of the market for the last few years is because they have high parallelism of computing on the chip, and you can do all that with less chips, with less machines, and more GPUs. So the GPU or hardware accelerated compute came to this tsunami puzzle, and they enable running all these algorithms on top of lots of data to get 95% prediction of, in accuracy. So companies are predicting better, monetizing better, and if I think about humanity, cancer situations are getting treated much better, and so on and so on and so on in every single aspects of our life. So lots of the algorithms have been around since, as I said, 60s, 70s, but they didn't predict better than 70%, 80%. Now they predict 97%. So they know what's going to happen. They know what you're going to buy, what you're going to think, what you're going to vote. They know to predict what's going to be the best treatment profile for a specific cancerous patient with the history of his family and other people with the same cancer with a specific type of DNA that he has. So the profile of treatment to people is going to be much more successful, right? So this is just a very important aspect of what we can do with the algorithms. And again, if an insurance company or a bank wants to predict who's going to churn, who's going to move to another company, they can predict that today with 98.5 or 99%. They couldn't do that without the data and without the algorithm. And of course, algorithms are advancing and data sets are growing. And what you need is to be efficient and be able to cope with all of that with the compute. So this is what SQream is doing. SQream is a data processing engine for very large data sets and complex algorithms that is running natively on GPUs. This is exactly what we do.
How do you do it differently that, that separates you from the competition, that has made you so successful?
If we look at the market, most of the market is still using architectures that are CPU based in order to crunch the data, ingest the data, transform the data, analyze the data, run the algorithm. We do it natively on the GPU. This is the difference. When you talk with a company that is working with Snowflake. So Snowflake is, CPU-based algorithms that is integrated to GPUs. So you run all the data ingestion, transformation, and analytics on a CPU architecture, and you integrate the GPU to run the algorithm. And at SQream, we are doing it at the same place at the same time. So it's more efficient, can cope with much bigger data sets, it saves you a lot of time and a lot of money. This is the difference about us. It's natively running on GPUs. So referring to the chess situation in the 90s and right now. So right now you have much better compute power, including GPUs, but on the smartphone, it's much better than what it used to be. You have better algorithms than we have in the 90s. They are actually machine learning and AI algorithms and not the plus-minus types of algorithms that we have in the 90s. And we have so much data about chess that was aggregated and all the models ran on them. So when a computer is playing against a human being today is much stronger in orders of magnitude more than what it used to be in the 90s. In the 90s, with compute that was limited but advanced, with memory that was limited but advanced, and with simple algorithms, they got to the point that a computer was winning against a world champion. It is still difficult to win against a world champion with chess, but the chess and compute became extremely strong. So I would say when a chess software is playing against an amateur, it is on a strong level. It's most likely that the chess program is going to win because they are much better. Still, it's going to be difficult for them to win against Grandmaster, but it is happening much more.
Does that take some of the excitement out of chess, knowing that it's basically?
I don't. If you put compute outside, and people are playing against people, it's still the same art, the same science, the same logical fight between minds. When you put compute into that, you kind of miss.
It ruins the. It's not the game.
It's not the game. It's not the game. We just had a competition here in the building between people, and it was fun and great. We really liked it.
Awesome. You had me wondering, thinking, I don't know if this is any relevant to you. You're saying that the AI and the data, right? Obviously, more data, the better, the more things are predictable. Do you ever look at all of this data and how well you can predict certain things and decisions that an individual may make and wonder that do we even have free will? Does it make you question free will?
Yeah, so I'm not...
I know you're not a philosopher or anything.
I'm not a philosopher.
I know you didn't mean I expected that question.
I would like to think the positive achievement that humankind can achieve, can get to with the compute data and algorithms towards making the world a better place are far more important than the other side of the same thing, right? So I do think that, and one of the lessons the world is learning is from the old, trillions of dollars invested into autonomous cars. It's not there, right? It's still going to be difficult to make a car completely autonomous and safe because it's probably more complex than people thought 10 years ago. And we think we're going to have a level 5 autonomous cars in the next decade, not in this decade, in the next decade. So it's going to take much longer.
Really? I saw people already... Tesla's new full self-driving looks like it's relatively autonomous now.
If it comes earlier than that...
I mean, I don't think it'll be adapted to the market for a while, but I think the technology is already here.
Yeah, and this is, by the way, a good thing. This is a good situation because if it's a flawless driving, the human mistakes are out of the picture and we have less accidents. So I'm all for it, but I still think...
Also, the time it frees up, I was thinking economically it frees up. And the traffic that it frees up when cars can communicate to each other. We may not need traffic lights. Everyone just always be going.
I'm a big believer in that for humanity. So this is a good problem to solve.
Terrific.
But it takes much more time than people thought to get it to the level of completely self-sufficient. And also, you know, ChatGPT, right? Everybody talked about it. It is increasing productivity much more, but it's not replacing, completely replacing the people. So
correct.
If you were writing an article, you are much more productive with that with the ChatGPT. If you are looking for...
It's a tool. It's like computer. Your personal computer didn't replace you.
Yeah. So I think if you talk about assistance to humans, great. I do think there are some dark sides for that, and for these dark sides, we need to be very, very careful. Because
what are you talking about? Tell me about these dark sides.
So, for example, if they know what you're gonna buy tomorrow, this is a bad thing. This is not a good thing. If they know that you have a health problem, just because the way you talk to the microphone or the way you move the mouse, the way you respond on the keyboard, and they take advantage of that, that's a bad thing.
Right.
If they know what's going to be...
Who's they?
The people who owns the data, that can be, and I'm not saying they are doing that. I'm just suggesting that this is a bad thing.
Right.
Right? If they do it. But all the owners of the social networks in the world, the people who are talking a lot about TikTok, right? And they know everything about you. And Google knows everything about your movement in the world. So I think TikTok, Facebook, Google, and all the owners of all of our data on the mobile phones and on the net, they can do spooky stuff with that. And I'm not saying they didn't, and I'm not saying they are.
Right.
But I do think that some implications of that are pretty dark, including well-known situations when companies are being charged of trying to manipulating votes in countries, right?
Yeah.
And again, I think it's a dark thing. I think the fact that someone knows what's going to be the results of the US election in a few months, or someone can impact that dramatically with AI, this is not a good thing, all right?
Right. Well, we've been doing this not with AI, but this has been done for a while, right?
Yeah.
I mean, manipulating through social media and governments are involved.
So marketing-wise, again, something, I don't know if this is good or wrong, but I can tell you that for sure some of what is done with marketing today is manipulating human brains with data, right? Especially the stuff that you get into your feed that you think is you have the idea that it's not curated, but it is carefully curated towards something, in order for you to buy something, in order for you to think something, or in order to know what you think and what you want to buy. So there's a dark methods for that, and there are okay methods for that. You know, we are being monetized on since the 90s on the internet, and some of it made our life better, right? I am pretty happy when Uber is finding the best driver for the shortest route for the best price for me, right? And this is based on my preferences in the past. So is this good or bad?
Right.
I think it's good.
I was using Waze with the GPS in the car wasn't working because of the war. And so both my wife and I both opened up our GPSs for the location. I just opened mine. I had her open hers because she doesn't know how to use my phone because she's Apple and I'm Android. And our destinations were different. Mine was like 4 or 5 minutes faster. And so I was like, that's weird. So I had her like, look at the maps, see like the turns are identical because I drive faster than her.
Yeah.
So
exactly.
It even knows my ETA in ways, or we're not talking about the same thing. This is more accurate because of how I drive.
Yeah.
Yeah, my wife wasn't happy to learn that.
And I have the same phenomena with my wife, going to the same place with the same car, different times. Different times. By the way, they also know the difference between the cars. That was surprising for me because we did that experience in 2 different cars. But again, this should be balanced. And what I want to say is something that we encountered in our business, right? So sometimes regulation and you know, making sure people data is private is actually stopping solutions for humankind. And I'll give you a specific example. I think that the world has enough data and enough digital history to make unbelievable advancement in curing cancer. All right? We have enough samples of DNAs. We have enough history, digital history of patients that they got some kind of a treatment. We have the algorithms and we have everything. But because of certain regulation issues, there's a huge issue to merge all these together, right? So let's say someone comes with a specific case of cancer. There's history about it. And in a click of a button, I should be able to get the history of it. I'm not talking about AI right now. I'm talking only on data.
Right.
So the history, and I would say not the intelligence, just the history about all of these cases and what treatment went well and what not, is being augmented with DNAs of all the people and algorithms running on all DNA. So we can be more accurate with exactly what to do with these people. What about avoiding cancer? You have all the data.
Right.
You can predict who's going to get cancer in what age and why, all right? But because of regulation, there's a real issue to merge all these data sources and give the machines enough time in order to get with cure, with preventions, and so we need to balance progress for humanity with progress for monetization. Let's say that, all right, to be polite with money. So I think that it's worthwhile to save people's lives in order to maybe find other solutions for all these religiously, privacy regulations. So think about the fact that we could cure cancer. We could avoid chromosome-related sickness. We can, you know, make longevity a real thing, and we can do that in 98.5%, just like the marketing conversion algorithms. We have the data, we have the compute, we have everything that we need, and I don't think that governments and societies are doing enough, because they don't realize that the value of that is going to be healthier people, happier people, and safer places to live.
Do they not realize it, or do they not prioritize it?
Incentives.
Okay, so they don't prioritize it, right?
So if governments were incentivized by the health of their citizens,
right,
maybe that was a higher priority. But I think it should come from us. It's our interest that our government
us or
will
who,
put
individuals, businesses.
Yeah, the government will prioritize health, transportation, and the usual stuff they take responsibility for, but not necessarily put in the higher priority. This should come with the people, and balancing that without getting too much into privacy situation. And it can be done, and technology showed that it can be done. Look at all the things that they are doing with brain replacement in order to help people who can't talk or cannot move their hands. Recently, there was something that was published that shocked all the society. This can be done in order to cure cancer, not only to replace a certain activity of a brain. So I hope that with the more clients and the more organizations that are using SQream, their eyes will open and they see, oh, we actually can analyze all this data and do whatever we want with the data in order to get results. So it's not only SQream, it's of course NVIDIA and other technologies that can enable that. So to close it, we have enough data, we have enough algorithms, we have great algorithms, and we're going to have more algorithms, and we're going to have more data, and we have the compute in order to do so. So I think the world needs to focus more on the basic stuff, you know, agriculture, health, commute, and all the other things in order to get the solution to assist us, not to replace us, to assist us live longer and happier life.
So more about SQream. How did you guys start? How did you come about? And maybe a little more about your business model. Because obviously, you know AI, you know machine learning, you understand data, you know how to use it to make this thing functional. But what made you think that there was a market need for it? Or how did it come to be? Or maybe you want to take us back in your career and how you got here?
Yeah, so in my first company that was high performance call center company, we got into technology limitation of scale. That was in '98, and it was too much data and too much to process for the compute and data bases that were available at the time. It was '98, it was the best database on the market, Oracle 7.3.4 or 8, and it was Sun Solaris machine, Unix. So the best technology on the planet, the most expensive one, with the best machines on the planet, and with the best database on the planet. It was too much data in order to process in the time frame that we had. So I was building. I used to be a gamer, so I liked. It was called screen cards, later called GPUs, and I knew that on GPUs there are many computing cores. So what I tried to do at the time, was a builder. So I built a machine with an extra 2 GPUs, and I tried to take the algorithm that was running very slow on a very advanced CPU to try to run it on a GPU. The whole thing was called GPU, General Purpose Graphical Processing Unit, and I failed miserably. It didn't work. It was working slower. I don't want to get into that, but I was playing with general purpose graphical processing units for a very long time. Before that, we ended up solving the problem in a different way, and the customer was happy. But I was still playing with that and high performance computing using GPUs. And in this company was conceived when I was in a pitch festival of startups, when a founder by the name of Kostya Varkin or Konstantin Varkin came up with the idea of using GPUs to do algo on demand in general. And I asked him, and he was the name of the company was GPU Stream. All right, so I can tell you that everybody went back to their Blackberries and iPhones. That was when Blackberries still existed, and I was intrigued because GPU Stream. It sounds to me something that I like. I started to talk with Costa and ended up that he was trying to solve a problem that I couldn't solve in my previous startups on doing a join, a SQL statement with a vector processor, with a GPU.
Wait. For those that don't understand what you just said, can you explain that?
Yeah, so when you try to find, let's start very easily. SQL is the standard query language. When you have data and you ask a question, the data, usually you do it in SQL. And let's say I want to find all the people with blue eyes that lives in Tel Aviv, right? So I take a big table of all the people in Israel. Where are all the people with blue eyes in Tel Aviv? Very simple. But I also want to know where are all the people with blue eyes in Tel Aviv that have more than one car. All right, this is a different table, right? This is a table of all the cars in Israel, and let's say the ID of the person is the unique. So give me all the people from Tel Aviv with blue eyes that have more than one U car, and this is a join. I'm joining the table and I want this list. This is a very simple join, and this is a tactical query. This is not machine learning or AI or anything.
I've been doing this in spreadsheets forever.
Very simple. All right, and you get more and more dimension. You can do a 12 dimension, 12 tables, and the insights are extremely interesting. And all of that data is fed into an algorithm that brings you a prediction. All right, so A vector processor is like a graphic, like a GPU, is only looking at the colors and if to light the bulb or not. What color? You know, every pixel on the screen has its own processor. That's the idea, to get video in high quality, fast, and gaming was the first implementation of that. So the mathematics are different, and it was perceived impossible to do a join with the GPU effectively. And he came up with the idea of how to do that. I thought the application of algorithm on demand was not the best application in the world at the time. And we sat together with my co-founder and CTO Razi, and we ended up with data analytics accelerations with GPU. And this is how we started the company. It was based on our love to graphical processing units and high performance, and data and querying data. So we thought it's going to be much more data. Algorithms are going to advance, and in order to do so, it will be impossible to cope with the existing architecture. So here comes the GPU, a computing card with thousands of computing cores. So it's like miniaturizing a whole data center into one box, and we thought that's going to be pervasive for the industry. This is how the company started, and we didn't think, I'm not gonna say honestly, because everything I'm saying is honest, right? But
of course.
But I'm gonna be blunt here. I didn't think that this company will actually have customers and go to market and plans to go IPO. I thought that the big giants of the time, I'm talking about the end of 2010, beginning of 2011, the giants were Oracle, IBM. I didn't think they're gonna let us live through to be a company. I think I was absolutely sure that after less than 2 years they're gonna buy this accelerator for their own technology stack, and it didn't happen. And we had to build a company. But we started with the idea.
It's not surprising in hindsight.
Yeah. By the way, I have a small interesting story about that, and I don't mind. One of our first design partner was IBM. All right. And they came up with the idea, well, if you can accelerate queries on DB2 of IBM with your technology, that's very interesting for us. So they landed us the option to work on their machine with the GPU. It took them time to get it, and to show them that their own queries are running faster. And I remember the POC days was a great day. We showed them it was 20x faster. Wow, everybody were extremely happy. And then we brought a potential customer for the whole thing. That was a certain unit in the army. And they were happy. Well, 20x faster, we want to test it right now. Just one thing. Yeah, what? We needed to be certified by IBM because if it's not certified by IBM, we can't use it. And the guys at IBM, it's okay, it's us. We are the ones who brought this startup to the IDF, blah, blah, blah. No, we need an official certification from IBM at Rochester or wherever they sit. The guys at IBM there said, are you messing up with our database? No way you're going to get certification. We do not, that's the answer. The answer was, we are not accountable for the results of the database if you're using this technology. It was a big no-no. You're not getting a certification. And we went to a few other, and the guys at IBM here were also very frustrated because they were part of the whole idea. Anyway, to make a long story short, we didn't get certification, not from IBM, not from Oracle, not from everyone. Don't mess with our database. And this is where we did the pivot of the company. And instead of being an accelerator for other databases, we were our own data infrastructure.
Love it.
And I didn't think that we're gonna write a database. When you start a company, you want to build something that is going to compete with Oracle and with IBM, with Microsoft. No, we want to accelerate that. But we had to do it, and didn't sleep for a month, and we did it. at that point we understood that this is probably not going to be a quick technology sell. We will actually need to build a product, sell to customers, and build a large company that will.
Is your goal to exit or to scale?
So you see this number, $9 billion.
Yeah.
So we want to IPO the company. We want to compete with the likes of Oracle and IBM. By the way, they are not the giants anymore.
Yeah, I know. That's why I said it wasn't. They didn't. Yeah.
Now the giants that we partly compete and a lot collaborate with are AWS, GCP, Microsoft Azure. The cloud platform and the big data companies are either competitor or collaborators.
Yeah, funny that works.
And by the way, today with Oracle, we are collaborating much more than competing with. They are one of our main partners. So the company was conceived because I thought it would be cool to run a query on a gaming chip. That was the reason why the company was conceived. And I thought in less than 2 years, someone will buy this idea and sell it to customers, right? Because I wasn't planning to do so.
You were saying something interesting that like you thought you were gonna earlier. You were saying you're gonna partner with these other companies and that, and you're like, well, screw it. Looks like we got to do it our own way and build it our own. I'm finding that this has been kind of an Israeli cultural thing, especially in the tech ecosystem, and I'm hoping it expands beyond that. That you know, when there isn't a way, when you hit a wall, when you hit the bureaucracies or the regulations or the headaches of these larger companies, being able to be a startup, especially outside of America, you're able to go ahead and build really cool and pave out your own way. Yeah. And you can get your attention, then they end up coming to you. I see parallels also just with the war, similarly with just like, you know, Israel couldn't get weapons they thought we had partners with, we'll have to do it our own way. And wait in a generation, they'll be coming to us for weapons, you know? It's only how it works. You box us out, then we do it our way, and then you want to come to us in the end. Because you were corrupted then, why it didn't work with us, and now so because you're corrupted, you can't build your own technologies. You can't, they're not going to last. That's why the giants of yesterday are no longer the giants of today. And if the giants of today will be the giants of tomorrow, they need to learn how to collaborate and do that. And NVIDIA is really great with that in particular. What's your relationship with NVIDIA?
We have a great relationship.
No, I know that. I see that you're pretty active, so I'm trying to understand that better.
So NVIDIA was focusing on chips. You know, they have fantastic computing chips, and they now have the network hardware as part of their acquisition of Mellanox. And recently, they started to get into software because they want to, you know, to be not only on the side of the algorithms in the data center, but they want to be the processors of the data center, and we come very handy achieving that goal. So recently they started to invest, acquire companies in the software realm, including 2 acquisitions in Israel. I don't think that was incidental. I think we're going to see lots of software coming from NVIDIA through own development, through partnership, and through acquisitions in order to be the main processor in the data center. So our architecture is based on CPU and GPU, and the heavy lifter is the GPU. So CPUs are going to be there either from Intel, AMD, or NVIDIA. NVIDIA just released their own CPUs. But the main data processor, this is where we come in, and they see that, and we collaborate quite a bit, going to the market and thinking about next generation designs of architecture of such a platform. So our vision is, we have a lot of things common in the vision. We want SQream to be the main processor of data inside data center. NVIDIA wants to be the main processor within this software stack. So it comes together as part of many things they want to do in data center. But data processing at scale is like one of the cores of their vision, and it's all of our vision, all right? So AI, machine learning, data science, data crunching, all of that is part of the vision of us and NVIDIA. So we are a software stack on top that is taking advantage of their processor. definitely joint vision.
So you're talking about what you're doing, and you have large objections, obviously, for you to grow and be a leader. Who are your customers now, and how do you see maybe who your customers, maybe they're going to change in the future in order for you to reach the objectives that you have?
So we have a few types of customers, and we've been very successful with companies that the characteristics of what they do is the following. They have lots of data in the get-go. They have lots of data every day, every minute, every hour of new data. It's extremely important for them to get the insights or the algorithm results fast, and they want to be cost effective, all right? So you take that behavior and we find that quite a bit in telco operators, plenty of mobile phones creating data on us every second, and they want to get the insights extremely fast and to be cost efficient. Semiconductors and manufacturers, they collect zillion of data points in their fabs, and they want to improve the yield of the fab, so 99% of what they produce is legit and workable. So we have that, and we have quite a bit of a growing interest and customers in everything financial. That's banks, financial services, insurance companies, payment companies. So, and I can't mention all the names, I will mention a few, but we are, Samsung is a big client of us, a few divisions in Samsung. LG is a big customer of us, a few divisions of that, both the telco and the semiconductor. Texas Instruments is a large customer of us, and the list is pretty long. So this is main type of customers that we have, and they go all the way from tens of terabytes to petabytes of data. And by the way, our business model is based on size of data set. So how much data we process is the thing that you pay for us. So we grow nicely with the customers because they start with 50 terabytes and they move all the way to 1 petabyte of data, and they need to pay us more. So we grow with data sets that are growing all the time, and we grow with use cases. But they're not bad. But if I look at where we're going, is we see more and more clients and prospects that from not necessarily semiconductors and financials and telco. We see in retail and e-commerce, with advertising technology, healthcare, homeland security, cybersecurity. The difference between an algorithm that runs on large data sets, between an algorithm that runs on a filter data set, is huge, right? So we see more and more requirement for something that can cope with such big data sets. We also have a product line that we acquired, a company that we acquired it's called Panoply, and it is for people without knowledge about how to do data engineering and still be able to get insights without, just clicking a few buttons. I work with Salesforce, with NetSuite, with Stripe, and I want to get a dashboard. What's going on with my billing and customer? So you click a few buttons and you get it. So it's like the world's easiest self-service data warehouse for newbies that they have no idea how to do that. And it's a lot of times it's departments in large companies. They start their journey with insights with that product, and they move to the bigger product, SQream Blue and SQream Enterprise. So it's kind of a lead generation to our main product line. And they also helped us put SQream as a service. And we just launched it, SQream as a service, SQream Blue. The way we look at the future, and again, the future is we want to beat Oracle, and we want to beat Microsoft, and we want to beat IBM and Snowflake and Databricks. These are all giants in data, or collaborate with them, right? So with a lot of them we compete sometimes and collaborate even more from a technology that was completely invented in here, completely developed in Israel, and we want to have Tel Aviv and Ramat Gan and Beersheba and the whole country of Israel as a leader in AI, data, machine learning, and in the future of the industry. So I'm really one of the things that are motivating me is the fact that our smallest competitor is IBM, right? So it's and to relate to something that you asked me, I don't know if it was offline or online, but when you get to a geek like myself, right, with all this marketing front office of myself, I'm a geek, and I like gaming and I like technology. When you tell someone like myself that we can't do that with IBM, or this is impossible, or forget about it, writing a database, are you crazy? This is a source of motivation for me.
Right.
When someone tells you, oh, well, forget about IBM and Oracle, you compete with AWS. I think for the types of entrepreneurs and technology people in Israel, this is a motivator.
Right.
And not the other way around.
Right.
And when, I don't want to say when the going gets tougher, the tough gets going. I don't want to say that. I just want to say that, Baruch Hashem, right? We had so many macro challenges in the last 5 years, right? I don't want to say even COVID, but we had financial crisis and banks were falling down, and we had this whole internal turmoil in Israel in 2023, and many other things, and then came October 7 and completely took the mat under our, everything changed since then. So at the first look at it, it is, you know, demotivating, right? It's tough enough to compete with Oracle, right? So what do you want from me? COVID, financial crisis, nobody wants to invest in Israel, and then this war. It is bringing you some tough moments. However, the fact that we are together in this, the fact that so many brains here that really want to show that we are here to stay and to win, not only on the war, and I hope we're going to get our people back as soon as possible.
Amen.
We need to win in business. We need to win in technology.
Amen.
We need to make sure everybody understands that this is not a cameo of 77 years. This is like a zillion years enterprise, Israel.
Yeah.
And we are going to show everybody that we're going to help cure cancer, and we're going to bring the ability of the technology to the lives of all the people on the planet, even though someone wants to kill us. All right, so it's actually unbelievably, but it is motivating, and
it makes us stronger too.
Yeah, and I think we had, yeah. I really wish we wouldn't be occupied by getting our people back and having go through the atrocities of the 7th of October and later on, and be in a world that someone actually thinks this is okay, right? And sometimes you talk with these people and you need to listen to unbelievable thoughts that people have on what happened, and you need to take a decision. Do you want to work with this guy, yes or no? Of course you don't want to work with him, and so on. This affects the business every day. But again, we have people that went to Miluim, to reserves, for 4 months, 5 months. Now we have people that are crossing the 7 months of reserves. This is not making life easier, but for the cause that we started, we wanted to show the goyim, right? We wanted to show that we can build the leading data processing technology from Israel against the giants. And we're going to do that even though we have people in reserves. And it is motivating. It's tough. I don't think the people in Boston that are running startups for data processing
right. I know.
Have the same challenges that we have here. But and we're going to make it even though this was happened. So it was important for me to say that we still have plans to build the largest data processing company in the world from Israel, and to serve society and enterprises from Israel. And again, if someone really, if a company like NVIDIA, they come with a check of $1.87 billion tomorrow morning and tell us, you know what, we think that together with us, this technology can go faster and further, maybe we should consider it, you know, pragmatically. Maybe this is going to be something to consider. But still, we want to build a large company with that.
I love it.
Yeah, me too.
I mean, so there's a couple things I was thinking about. You were just saying such great things. I didn't want to interrupt you. The first thing I found fascinating, you're saying there's similarities. You know, you're saying that the giants before in the industry are no longer the giants now. And I think Israel's always been around, as you were saying, thousands of years. And whereas a giant, I think we have so much pressure and challenges ongoing that we are forced to innovate. I don't just mean tech-wise. I mean in every way, aspect of our livelihood and living, that it helps us become even bigger and stronger into the future.
Yeah.
That it will be even, in my opinion, even a greater giant in our own way in the future. People won't say, oh, they were once something and now they no longer are. And I think it's because we're able to overcome it. And just like even as you're challenging your competitors, right, the giants that they are, if they take you seriously, they'll be better companies and they'll have and as long as we take our challenges seriously, step up and overcome them, we're going to be better. We already are better, faster, but even faster, better, more efficient.
Yeah.
You know what I mean? Much greater morale of a workforce than you can find anywhere else in the world.
Yeah.
Thank you so much for being on Israel Tech. This is a terrific conversation. I love what you're doing here for AI, machine learning, and really developing almost like a sub-industry. I think that brought this lead here, so it's a true honor. And to keep everything that you're doing here and keep growing in Israel. And we love what you're doing here. And you brought a really warm message to everyone in the whole tech industry in the world and in Israel in particular.
Thank you for hosting me. I really appreciate that. And I'm looking forward to build stuff together. And I think what you guys are doing, giving back, making sure the sound of Israeli technology is getting to the world is great. And more people should come and join this venture.
Awesome. You can find all links of everything about SQream and Amigal downstairs down in the description.